Question 4, part A. Write the square root of 240 in the form a root 15. So what that means is that we can simplify the surd in such a way that it's going to become the square root of something times the square root of 15. Well, if we take 240 and divide it by 15, what we will end up with here is a square root of 16, which simplifies pretty nicely to just being a 4. So 4 root 15 is our answer, which basically means a is 4. Part B, expand and simplify. So we're looking to multiply each of these terms in each bracket with everything in the other bracket. We have a 2 times 5 for 10. We have a 2 times a 2 root 3 for a 4 root 3. We then have a negative root 3 times a 5, which will give us a negative 5 root 3. And lastly, a negative root 3 times a 2 root 3, which will end up giving us a minus 2 times 3, or 2 times root, you could write it as 2 root 9, which then becomes a 3, and that last term is going to become a minus 6. And then 10 minus 6 will give us a 4, and a 4 root 3 positive, and a take away 5 root 3 will give us a minus 1 root 3, which we can just write as minus root 3. Last but not least, part C, simplify 2 plus root 5 all over 3 minus root 5, giving your answer in the form a plus b root c, where a, b, and c are rational numbers. So no surds for a, b, or c. Although c itself is going to be underneath a root, making it a surd. Simplifying a denominator that has a surd in it, we're going to have to rationalize this denominator. Because there are 2 terms to this, we're going to have to multiply it by its conjugate, or in other words, the same 2 terms, but a plus instead of a minus. So we're going to multiply by 3 plus root 5. We must do the same at the top in order to make it so it's the same size, and then we'll need to put brackets around these because there's more than one term involved. So being careful with how we expand all of these out, we have 2 times 3 to give us a 6, we have 2 times root 5 to give us a plus 2 root 5, root 5 times 3 will give us a 3 root 5, and then a root 5 times a root 5 gives us a 5 on the top, like so. On the bottom, you can do the same and break out these in the way that I just did in the top bracket, but what you're going to have here is because you're multiplying by its conjugate, you end up with a difference of 2 squares. So the first term squared here will give us 9, the second term squared here will give us 5, and then the difference of those is what we're going to end up with. Simplifying that, we have a 4 in the bottom, the 6 plus 5 in the top gives us 11, the 2 root 5 and the 3 root 5 added together give us a plus 5 root 5, and that's what we've got so far. But because of what I've highlighted there in green, you cannot leave your answer like this because it is a single fraction and not as 2 separate terms as shown here. So we have to take this and write them as separate fractions. The 11 is over 4 on its own, and the 5 root 5 is over 4 on its own. And even better than writing what I've just done there and writing it all over 4 would be to identify that you could just write it as the 5 over 4, like so. It is the same thing at the end of the day. A will be 11 over 4, B will be 5 over 4, and C is what's under the square root, which is 5. You don't need to write this at the end, but it's quite a good habit to do that for these questions where they ask you to express in a given form, and then they're highlighting stuff about A, B, and C. Certainly if A, B, and C end up being, say, something that was a fraction, and the question said something about integers, then sometimes doing this can just make it clear that we're not done yet. However, we are done. They're all rational numbers. The end.